Right, hey everyone! So I want to talk about solving radical equations today, and just like any other math problem, we need steps to solve radical equations. Now, what's a radical equation? A radical equation takes on, it's in a radical basically. So let's say you have like square root x plus 4 is equal to 5. Something like this is what we want to solve today. Okay, so just like any other, math problem, we have steps. So have the nth root on one side of the equation. Basically, have all your radicals on one side of the equation. Second, raise each side of the equation to a power equal to the index of the root to eliminate it. So if you have square root, and then you're going to square it. If you have a cube root, then you're going to cube it, and so on and so forth. Then 3, solve the equation as you normally would using your algebra skills, your basic algebra skills. And then 4, check your solution, meaning to plug in your answer back into the original equation. So I want to work on a particularly harder problem today. So let's say we have, or actually let's start off with something simple and then we'll gradually go through it. Okay, so if I have x plus in a radical, x plus 2, that's all in my square root, and then plus 4 is on the outside, and I have it equal to 7. Alright, so here's my example. First things first, alright, follow our steps. Have the nth root on one side of the equation. So have the radical on one side. Right now it's with the plus 4. So I have to move the 4 to the other side. So I will subtract 4 on both sides. Doing that, these two would cancel out. 7 minus 4 is 3. Then I have the square root of x plus 2. Go ahead and bring that down. And I have the square root of x plus 2 is equal to 3. Okay, so let me just rewrite this. Square root of x plus 2 is equal to 3. So now we have this equation. Alright, step 2, it says raise each side of the equation to a power equal to the index of the root to eliminate it. So right here, my radical, that came wrong, square root is a square root. My radical is a square root. Okay, so to eliminate square root, I will have to square it. So I have to square this to get rid of the radical. And what I do to one side of the equation, I will also do to the other side of the equation. So that is 3 squared. And this becomes 9. And then the square root of 2 raised to the power squared is just x plus 2. Alright. Now I can solve the equation. Solve as you normally would. So I want x by itself. So I would subtract 2 to the other side. Right, this cancels out. 9 minus 2 is 7. And then finally have x equals 7. Just bring down your x. So x is equal to 7. And then finally, step 4, let's go ahead and check. So let's check for x equals 7. Go back to my original. So your original equation. It was the square root of x plus 2 plus 4 equal to 7. And let's do it when x is equal to 7. Basically, I want to see, is this radical equation valid whenever I have x is equal to 7? So let's plug it in. So I have 7 plus 2 plus 4. Well, 7, so let's do sucrose. 7 plus 2 is 9, so I have the square root of 9 plus 4. And then all of that is equal to 3 plus 4, and that's equal to 7. So yes, it does check out. It matches. Okay, so whenever I have x equals 7, then square root of x plus 2 plus 4 is indeed equal to 7. Now I want to go ahead and move along and also work on a harder problem. Okay, so moving along, I want to talk about another problem, solving radical equations. So in the previous example, we had square root of x plus 4, right? I had a radical on one side, and then I had a number on my other side, and all I had to do was move the extra number and move it to the other side. But what if I have a radical on both sides? Instead of just having a radical on one side, what happens if I have a radical on both sides? So let's look at this other example I got for you. And if I have the square root of x minus 12, this is equal to 2 minus root x. Okay? So I have a radical on both sides now. With a radical on both sides, well, you see on the left-hand side, it's already a full radical, but on the right-hand side, you got part of like a partial radical, right? You have 2 minus radical x, or 2 minus square root x. Okay, but the thing is, what you have to do here is, if you move that 2 to either side, well, it's going to be square root x minus 12 plus 2, minus 2, and then you're going to have negative root x on the side. So whatever you do with that 2, you kind of get rid of it. Nicely put, I guess. So what you have to do is, from here, is you basically have radicals on both sides of the equation, so there's not much to change. So you kind of would have to skip step 1, and then 2, raise each side of the equation to a power equal to the index of the root to eliminate it. Alright, you would just kind of go to skip over and go to step 2. You would immediately square both sides. Alright, so the first one is kind of easy to see because it's a square root, so it's going to be x minus 12. Then 2 minus root x, I'm going to use my FOIL skills here. So that's what we need to apply here. 2 minus root x times 2 minus root x, because now it's squared, you have 2 of them being multiplied by each other. So apply FOIL in this instance. Okay, alright, and so this is going to be x minus 12, and then here you have what? 4 first, what's 2 times 2, outside, negative 2 root x, inside is also negative 2 root x, and then outside is positive, well, root x times root x. Okay, so I'm applying FOIL, and then combine like terms as much as you can on the right side of the equation. So it's x minus 12, so you have 4 minus 4 root x, those are like terms. Root x times root x, that's just x. Okay, and then at this point, alright, we did step 2. Now step 3, solve the equation. So let's continue to solve this equation the best we can. Alright, but look here, you still have a radical, but it's in the middle, right? It's 4 root x. So our goal is to kind of isolate that and get that radical all by itself. Alright, so first things first, I can move my 4 to the other side, to the left-hand side. I can also move x to the other side. So when I do that, they cancel out on the right-hand side. So minus 4, put them with their like terms, minus x. Alright, so you get negative 4 root x. X minus x, these would also cancel out. Negative 12 minus 4, so that's negative 16. So you have negative 16 is equal to negative 4 root x. Then, so again, isolate that radical, right? Even though you have that radical, you want to get that by itself. So divide by negative 4, divide by negative 4. So these would cancel out, leaving us with just root x down here. And then negative 16 divided by negative 4 is positive 4. And now see, you have a radical on your right-hand side, and then you can go back. So I'm applying these steps multiple times in this sort of problem, just because we had a lot more radicals to deal with. So I will square both sides to get rid of this radical. And what you do to one side, you do to the other side. So now the root x times root x is going to be x, and then 4 squared becomes 16. So 16 is equal to x is your final answer. And then finally, go ahead and check. So we solved. Now we're going to go ahead and check. So check. Let's do our check down here. Over to the right. So our original, okay, I guess I'll just call it the OG. Okay, so it's x minus 12 is equal to 2 minus root x. This was our original. And when x is equal to 16, so 16, let's plug that in. 16 minus 12 is equal to 2 minus the root of 16. Take the principal root, the positive root, so you have what? 2 minus 4 on this side, and then 16 minus 12 here. So 16 minus 12, that gives us, what, 4? So square root of 4. This is 2, and then this is going to be negative 2, right? We already have that problem when we saw 2 minus 4 over here. Well, this doesn't work. This can't work out. Okay? So saying that x is equal to 16, this is not a solution. So this was our only solution, right? So since this was our only solution, we can say that there is no real solution. okay? Because I have it equal to a negative number, no real solution. Now you can also check the graph, right, and see what happens when you do, so graph the square root of x minus 12 and the 2 minus square root x, and then see what happens there. All right, you'll see that the two graphs, do they meet, do they not? If they Well, they obviously don't meet because they don't have a real solution. So it's possible that they meet on their imaginary axis. All right, so feel free to try that out, and then you can let me know. All right, thank you.